So let me first talk about a few rules that apply here. If you see the greater than symbol or the less than symbol, but without a line underneath, that's when you're going to use a dashed line in my math lab. If you see greater than or equal to or less than or equal to, so it's allowed to equal the line, that's when you're going to use a solid line in my math lab because it is allowed to equal that line. So far, so good?
Mm-hmm. Yes.
Okay. Also, if you solve for y, because I've already talked about my favorite way to graph is to get it in slope-intercept form. It's not the only way to do it once again, but it's a way. If you solve for y, if you ever have y is greater than, doesn't matter if the equal to symbol is there or not, then you're going to shade above. If you have y is less than, doesn't matter if it's equal to or not, then you're going to shade below your line. Okay? I'll talk about another way to do the shading as well, but I wanted to mention that because that's a shortcut that sometimes helps people out. So let's try to get the y by itself here. How would you get the y by itself in number 59?
Subtract 8x.
Good. So now we have y is greater than negative 8x plus 4. So we've talked about this already, right? Your slope is negative 8, which you can think of as negative 8 over 1, and your y-intercept is 0, 4, right? This is something we've now done several times today, which hopefully just makes it clear that you need to be comfortable with graphing lines, right? Hopefully that's gotten across in today's review. Okay, so now we're going to graph 0, 4, and then use the slope. So what are we going to do?
Go down 8 over 1.
Go down 8 and then to the right one. Very good. Is this going to be a solid line or a dashed line?
Dash.
Dashed. How do you know it's going to be dashed?
Because there's no line.
There's no line.
Good. So it's going to be dashed because there's no line. It's not allowed to equal it. Okay. Are we going to shade above or below the line?
Above.
Above because of the greater than symbol. Good. So one way to think about that is go to a point on the line and then just go up from there. So this is going to be all shaded in using that paint tool in my MATLAB. Now the other way to do it that they talk about, which is a perfectly valid way, is that you can plug in an ordered pair and see if that ordered pair is a solution to the equation. So I do want to go over that because that's also a great way to do your shading. So let's say a lot of times they suggest you use the ordered pair 0, 0. So let's see if 0, 0 works. So if you plug 0, 0 into your equation, you get 8 times 0 plus 0 is greater than 4. So the whole left side becomes 0, right?
Mm-hmm.
Is 0 greater than 4?
No. No.
No. Okay. So you want to look at your graph and say, okay, 0, 0, which is right here. It's not a point on your graph necessarily, but I'm just indicating it right now. This is 0, 0, right? And we just figured out that 0, 0 would not be shaded, right? So that means you have to shade the part of the graph that does not include 0, 0, which is what we did here. Because the line always splits your graph into two parts, right?
Mm-hmm.
So you're either shading the part with that point if you get a yes answer that it works, or you're shading the part without that point if you get a no. Okay, so let's just try a couple more here. Let's look at number 60. So what would we actually have to subtract?
X.
X from both sides. Good. Okay. And then?
Divide the 5.
So this one might get a little bit messy, but that's okay. So we get y is less than or equal to negative 1/5 x plus 2/5. So the tricky part here is that 2/5. But 2/5, There is a way, if you mess around with it, to put in a messy ordered pair in my math lab. So there is a way, I think if you double click, that it actually lets you enter the coordinates and then you can type it in like an ordered pair. So I believe that you could actually in my math lab enter the ordered pair 0 2/5.
I
And
kept
it would
getting
let
it wrong because I didn't know how to put the fraction into the.
So there is a way. It doesn't let you automatically move to the point necessarily, but if you just like double click, I think on a random point, and then it lets you like type in the coordinates. So mess around with it on the homework or on the practice test before you do it on the test, but there is a way.
I just thought I was doing like the problem wrong.
No, you're not. There is another way I'll talk to you guys about that you could have approached the problem that might have also worked, but no, you're not necessarily doing the problem. It is a little tricky though, because here's the problem. If you do it that way, it might make it hard to go down 1 and write 5, because then you'd have to actually figure out what that ordered pair is. So if you were doing it on paper, it wouldn't be that big a deal because you could just go down 1 and write 5, but it's a little bit harder because you're now dealing with another fraction over there. The other option you could do if things are working out messy is do an XY chart like we talked about before and try to get numbers that work out a little better. So what you could actually do here if you're doing an XY chart is plug in numbers for Y would actually work out well. And then that'll give you some nice clean ordered pairs for X. So let's say we plugged in Y equals 0. You could do X plus 5 times 0, and you're going to just temporarily pretend you have an equal sign because you're not going to worry about the shading. So just don't worry about what the symbol is. So 5 times 0 is 0, so that gives you X equals 2. So you'd have the ordered pair 2, 0, which you can kind of see that we were about to go through anyway. Right? But then you could also plug in like 1 for Y, let's say. So what would that give you for X? So that would be the ordered pair -3, 1, which would be over here. So that would be another way to do it without having to mess with the fraction. So sometimes it works well to solve it in Y equals mx plus b, but sometimes it doesn't work as well. So that would be another time when you could go back and use one of the other methods, the table or the intercepts. Okay, now I did draw a solid line kind of accidentally, but it is correct. Why is it correct that it's a solid line?
Because it includes it.
Yes, because it's allowed to be equal to it, so it includes it. Good. And then at least when we did this, we can go over the shading again. Are you going to shade above or below this line?
Below.
Below, so it's going to be down here, which it would also work. It's hard to tell because my line isn't perfect. If you plugged in the 0.00, you would end up getting that 0 is less than or equal to 2, which does work. That would be a yes. So you would have to shade the part of the graph that includes 0, 0, which is the below part. Okay, so it works either way. Let's pretend for a second that it was the equation x equals -2. So let's pretend there's not an inequality there. How would you graph x equals -2?
A vertical line going through -2.
Very good. So go through -2 on the x-axis, draw a vertical line. Is this line going to be solid or dashed?
Solid.
Solid.
Solid because of the equal to sign underneath the greater than symbol. Good. Now with shading here, it's a little bit different. One way is if you want to know the rules, if it's x is greater than, if you think of like a number line, x is greater than means you're shading to the right, and x is less than means you're shading to the left, which works with like a standard number line, right? Think of the x-axis as like a standard number line. So here you would be shading to the right. Another way to think about it though is you can still plug in 0, 0. It's just not as exciting because you only have an x value to plug it in for, but that's fine. Is 0 greater than or equal to -2? Yes, so you're going to shade the part of the graph that includes 0, 0, which we already did. So that works as well.